So we're ready to start on page 179. And what there is there's a Kramer's rule, and it's a way of finding individual x's. Kramer's rule, you take the determinant, and what you're going to do is whichever value of x that you're going to evaluate in the A matrix, you replace that column with the B. And what you have is you have AX equals B. So when they say A I B, for example, if you're going to do X1, what you do is you do A1B, and that means that you replace the first column in A with B, and then take the determinant of it. That's what that A1B would be, putting B in place of the first column. A2B would be putting B in place of the second column, right? That's it. And then like X1, if you made this specific, would be the determinant of A1B, putting B in place of the first column in A, and then determinant of A. So if you just wanted to calculate one or a few of the values of X, then you could do it that way. They're going to talk a bit about, on page 80, if you have like in Laplace transforms, it's in electrical engineering, they do it, and they have a parameter, and they want to find out what values of the parameter what it cannot have in order to make the solution correct. Now, that theorem 8, they're going to be talking about an adjunct. And the thing you want to notice is that when they do ADJ of A, it's equal to this. It's equal to cofactors. But what they do is you get the cofactor of the first row, first column, but the cofactor here is going to be rather than the first row, first column, it's going to be the second column, first row. You put that here. And then you'll do third column, first row. Understand? You're doing cofactors of all the rows, but then when you place it into the adjunct, you take rather than having the cofactor of 1, 1, cofactor of second row, first column, rather than putting this thing here, you put it up here. And then this one that's down here, the cofactor of the third row, first column, well, it will be, so this will be 2, 1, this will be cofactor of 3, 1. In other words, do you understand what I'm saying? An adjunct, you're not doing the cofactors straight down. You're taking them and putting them in. You're taking the columns and putting them into row. But these are all cofactors of the A matrix. Does that make sense? And that's what the adjunct is. So if you notice in the example, they're going to do the cofactors. They got that matrix A, and then they do the cofactors, and it's the regular cofactors of first row, first column, first row, second column, and so on. But when you put them into the adjunct matrix, then what you do is you put the columns and rows interchange. Right. And then the inverse. Notice that inverse of A is 1 over the determinant ADJ of A. The ADJ is the cofactors with the rows and columns interchange. So it's another way to do inverse. And all right, then and theorem 9 is saying that if you have a matrix, 2 by 2 or 3 by 3, and then if you do the determinant of that matrix, if it's a 2 by 2, the determinant is the same as the area that's bounded by the vectors of the matrix. And then if it's 3 by 3, it's the volume of the matrix bounded, or the matrix bounded by those vectors. And then there's the theorem 10 is the transposition of functions, or a transformation, linear transformation. And that's showing you that the area of that transformation is equal to the determinant of A area of S. So we'll do a few of the problems. And all right. So on page 186. And here it says use Kramer's rule. So that's Kramer's rule says what we have to do is we have to do those, replace the B into whatever xi we're solving. So the AX equals B, and what we have is we have this 4x1 plus x2 equals 6, and 3x1 plus 2x2 equals 7. So if we put it in that A, so we have 4, 3, 1, 2, x1, x2 equals 6, 7. So then our A1B is going to be equal to that A matrix, but 6, 7 is in that column. And then the A2B is an A matrix, and put 6, 7 in the 2 column. And then what we're going to have to do, we're going to have to find the determinant of A and the determinant of each one of these. So I do the determinant of 6172. It's going to be 12 minus 7. So that's 5. And then this one is 6. 28. And then the determinant of A. So the x1 is going to be the determinant of A1B over the determinant of A. So that's 5 over 5. And then the x2 is the determinant of A2B over determinant of A. So then, these are the answers. X1 equals 1 and X2 equals 2. I'll do 4. So this one is going to be the AX equals B. The A is going to be minus 5, 3, and 2 minus 1. X1, X2, and the B is 9 minus 4. So if I do the determinant of A1B, that's going to be the determinant, and I'll put in place of column 1, I put B in the A, minus 9 plus 8. So that should be a minus 1. And the determinant of A2B is minus 5, 3. And then put B in place of column 2. Minus 27 minus 7. Now I'm going to do the determinant of A. Minus 5. Minus 1. Equals 5. So X1 is the determinant A1B, determinant of A, minus 1 over 1. X2 minus 7 over 1. It's the reason they're using it, and we're doing pretty simple things because you get more complex. It's pretty hard when you do it by hand and you're trying to solve this. It'd be better to do a reduced echelon form of an augmented matrix, but if you're going to do it in a machine, sometimes, and if you have a large amount of X values and you only want to compute one of them, it's a little quicker. So I'll do number 6. Let's see what the more. So I'm going to do the A XB. So it's 1 minus 1, 3, 3, 0, 1, and 1, 2, 0. X2, X3, 4, 2, 2. So the determinant of A1B is going to be 4, 2, 2, 0, 1, 2, 0. Okay. So what do you think? What should we do? Any idea? Does anyone see an easy way to do that determinant? Do you want to just go down the second column or third column? You want to what's that? Yeah, and there's a 0 in that second column too. So we could do whichever way we wanted to do it. So if we wanted to go, what do you want to do? Go down the third column? That's what you're thinking? Everyone doing the same? So it's a minus 1, and then I'm starting in the first row, third column. So 1 plus 3, and then it's 1 times the cofactor, 2, 0, 2, 1. And then it's a plus a minus 1. And then it's going to be the second row, second column. Did I do that right? First row, third, no, second row, third column. I thought it had to be a negative. 2, 4, 3, 2, 1. So this is going to be 2 minus 2 times 4 minus 6. times a minus 2. That's 6. Is that right? Is that what everybody got? I just want to make sure I do it right. Okay. Then we're going to do the determinant of A, 2, B. So now it's going to be 1 minus 1, 3. 1 minus 1, 3. And we replace that second column with the 4, 2, 2, and then go 1, 2, 0. Probably that third column is the way to expand it again. So it's a minus 1, first row, third column, and minus 1, 2, 3, 2, plus a minus 1, second row, third column, 2, 1, 4, 3, 2. So this is going to be negative 2 minus 6, and it's minus 2 times 2 minus 12. So minus 8 minus 2 times minus 10. So that's a plus 20 and a minus 8. Is that what everyone got? 12? Are you already way ahead of me? Now then, the determinant of A. And that's a 1 minus 1, 3. 1, 2, 0. What's that middle one? 3, 0, 1. We can go down that third column. It's a minus 1, 3. And that's a cofactor, minus 1, 0. And plus a minus 1, second row, third column, 2, cofactor, minus 1, 3, 3, 1. So this is a minus 1, and then it's plus a minus 1 times 2, 1 minus 9. Is that what everybody's getting? So then if I do x1, oh, I do. Okay. Did you do it already? What? Okay. All right. So let's do the determinant of A, 3, B. 1 minus 1, 3. 3, 0, 1. Then we replace 4, 2, 2. Go down the what? Second column. Do a minus 1. First row plus second column. 3 cofactor minus 1, 2, 3, 2 plus a minus 1, and that's going to be down there. That's third row, third column, second column. And it's 1, and then that's that cofactor. 1, 4, minus 1, and 2. Kind of ran out of room. So this is a negative 3, isn't it? And then it's negative 2 minus 6. Then this is a negative plus a minus 1. And then it's 2 plus 4. Negative 3 times minus 8 minus 2 plus 4, 6. 24 minus 6. Is that what you got? So 15 is going to be, when we do the denominator, the x1 is going to be the determinant of A1B over determinant of A. X2 is the determinant of A2B over determinant of A. X3 well, this one is 18 over 15, isn't it? And the rest of them are all over 15, because that's determinant of A. And 1 is 6, and 2 is 12. 6 and 12. So this is 2/5, right? And this is 4/5. That was 18, okay. And so that's 6/5. So that should be the values. Is that what you come up with? Okay. Ran out of time having fun.